Hello, I'm Jeroen Blinder, VP of Product at Rhino Health. I'm going to walk you through a demo of the Rhino Health platform. A few things I'm going to cover in this video. I'm going to show you how you can use the Rhino Health platform to work on distributed data sets or data cohorts that can sit behind the firewalls at different healthcare institutions. I'll show you how you can compare summary statistics across these cohorts, run customizable code, and run federated training using NVIDIA's Flare SDK. I'll also cover a few different user interfaces, including our graphical user interface and our Python SDK. So let's get to it. This is our cloud-based graphical user interface. As a project lead, I logged in and I can now see these cards indicating all the different projects that I'm currently associated with. Each card shows me the name of the project, a description, some pictures of my collaborators, and the status of the project. I'll jump into the demo project. In this project, I can see that a few actions have already taken place. I can see that the collaborators have been onboarded, a data schema has been defined, and 2 cohorts have been imported. Let's look at the data schema. So a data schema is a mechanism by which we enable the user to make sure that data is harmonized across the different sources. In this case, the input schema was defined as containing these fields: a DICOM series UID, height, weight, gender, all metadata, and a label of whether there is or is no pneumonia in the study. I can also use the schema to define parameters. For example, height is limited to be greater than 0 and less than or equal to 2.3 meters in this case. And our system performs data validation to make sure that the data that is imported is within these parameters. So let's look at the cohorts. Each of these data sets represents a different site. If I go into one, I'll immediately see some summary statistic visualizations which match the schema that was defined. Another capability that Rhino Health provides is the ability to securely access the actual underlying data. This is, of course, depending on appropriate permissions being defined. If I click on the Data tab, I can see a glimpse into the actual tabular data, and if I click on the DICOM series UID, I will open our integrated OHIF DICOM viewer, which enables me to have a direct view into the image data. This fully functional viewer enables me to do all of the basic functionality of viewing an image, including adding some basic annotations. Now in this case, I have 2 cohorts. One great thing about the platform is that once I have multiple cohorts imported into the system, I get comparative analytics out of the box. In this view, you can see two items. One is this table, which we call the data completeness table. It gives me information about the completeness of the different features in each data set. In this case, I can see that while most of the data is 100% complete, some data is still missing, something that I might want to address. Additionally, I can compare the different features and different value distributions across the different sites. This gives me a view into what might be an implicit bias as a result of sampling. Now let's say I want to run some pre-processing on this data. Let's say I want to use imputation code to make sure that no data is missing. And let's say I want to calculate some value. For example, I have weight and I have height, and I would like to calculate BMI from these 2. So for this case, I've created some code. In this example, I've put together some basic code using sklearn's simple imputer to perform imputation on the missing values of height and weight. And then following that, I have some code to calculate BMI. I'm using very standard data science libraries for this. Now I would like to make this code available to run through the Rhino Health platform. To do this, I need to create a Docker container with this code in it, and then push that Docker container to a repository to make it available to the Rhino Health platform. To do this, we provide some tools to make it very easy. I'm in the data imputation library, and I use the Docker push script that was provided by Rhino. The script will enable me to create a Docker container and push that Docker container directly to a repository. I'm going to do this. This should happen fairly fast because I did this ahead of time and there's no update to perform. And that's it. Now that I've pushed it, I have this new URL that I can now copy and make that available to the Rhino Health platform. Let's go ahead and do that. Now, a reminder, I'm trying to add a new data feature here, which is BMI. In order to do that, I'm going to have to make a change to the data schema. So I'm going to go to the data schemas and create a new version. Using the latest schema, I'm simply going to add a new column, name that BMI, make sure that it is of the correct data type, so non-negative float. It will not contain any PHI, and I can now save it. I now have a new version of the schema, so my new code will take data that is in version 0 and produce data that is in version 1. Let's go ahead and create that model. I go to Models tab, create a new model. I'll call it Imputer with BMI calculation. It is a generalized compute type of model. It'll take data from version 0 of the schema to version 1, and here is where I paste the container URL. That's it. When I now click Run, the system lets me select which cohorts to run it on. I'll run it on both. And it allows me to provide a name for the output cohorts, or a suffix. In this case, I will add the suffix complete with BMI. Now when I click Run, what will happen now, the Rhino Health platform takes that Docker container, pushes it to the different sites where it will run locally on the local data, produce local cohorts with the results, and then import those new cohort results into the platform. If I look at my Model Results tab, I can see that it has completed with success 2 input cohorts and 2 output cohorts. If I go to my cohorts, I will now see the new cohorts complete with BMI. And in the analytics, I can now see that my data is 100% complete, and I also have this comparative view of the BMI. Great. Running federated training is performed very much the same way, except instead of creating a generalized compute model, I need to create an NVIDIA Flare model. This is the same type of container, except now the container will contain my machine learning code, which can be written in TensorFlow or PyTorch, or essentially any standard machine learning library, wrapped around with the requirements for NVIDIA Flare, and then create that container and push it. Now this will take some time, so in order to save time, I will show you what that looks like in a different project. So here I have created my prediction model. My prediction model takes data from the input schema and writes it to a new schema that we created, in this case, the results schema. I can show you what that looks like. Results schema has the same, in this case, same columns, except we've also added a model score column. When I want to run this model, I can select which cohorts to use for training. If I have cohorts to use for validation, I can define those as well. And I can add the different hyperparameters in these files here. I would then run training, which would set up the federated training network and run training. Again, that would take a long time, but essentially what that would do is produce a new cohort with model results. Now, what do I do with these model results? How do I make them visual? So for that, we've created another set of tools, and that is the Rhino Health Python SDK. Here's an example of the Python SDK. Essentially, the Python SDK is a Python library that you can install and then import just as you would any other Python library. And then you can use that to log into our platform. This will give me access to the exact same permissions that I have as if I were logging in through the graphical user interface. Next, I will load those cohort results, the results cohort from the project using a unique identifier. And let's say now, because these are classification results, I want to calculate an ROC curve. So I will import the ROC-AUC function and run it. What this essentially gave me is the calculation of the ROC-AUC values. I can now use those values to create a chart using my favorite plotting tool or any standard visualization library in Python. In this case, I'm using standard matplotlib. And here's my AUC, my ROC-AUC. We also have additional tools such as producing ROC with a confidence interval. Essentially the same, except I would run a different function, ROC-AUC with CI. And this allows me to produce this beautiful chart. Now let's say I want to perform some subgroup analysis. So for that, you can just add group by. In this case, we're grouping by gender. And here we have two different charts grouped by gender. Let's say I want to overlay those charts. I can do that fairly easy. And the next step would be to take all of these charts, put them together in a report that I can share through the platform. And we provide all the tools to do that as well. Done. Now, if I go back and look at model results for prediction, I can see that I have my model results performance report. I can now share this with all of my collaborators and whoever else I might be interested in sharing this with. And that's it. I hope you found this interesting. If you have any other questions, feel free to read more at rhinohealth.com and contact us at rhinohealth.com/contact. Thank you.